Our next topic is switching techniques. Switches. A switched network consists of a series of interlinked nodes. These nodes are called switches. The switches provide temporary connection between two or more links within a network. Here we have different methods of switching. There exist three methods of switching. First one, circuit switching. Second, packet switching. Third, message switching. Again, the packet switching is divided into two varieties of switching, namely datagram switching and virtual circuit switching. Let us see one by one. First one, circuit switching. What is circuit switching? A circuit switched network consists of a set of switches connected by physical links. Each physical link consists n channels by using FDM or TDM. FDM is nothing but frequency division multiplex or time division multiplexing. A trivial circuit switched network having 4 switches and 4 links as shown in the figure. Here, a trivial switched network has 4 switches and 4 links as shown in the figure. The circuit switching takes place at physical layer. Okay. The resources need to be reserved during entire data transfer process. The data is transferred as a continuous flow. There is no addressing involved when data transfer takes place. Means there is no need of addressing involved from when you are passing or sending a data from sender to receiver or from source to destination. Here in circuit switching we have 3 phases, namely connection setup, data transfer and connection teardown. We can say connection setup as setup phase. What is connection setup? For a successful communication, there is need to establish a dedicated circuit, that is end-to-end connection is needed. This connection is done by dedicated links to the switches. Okay. This is called setup phase, in which a circuit is reserved on each link and the combination of circuits or channels defines a dedicated path. This is the path. And next one, data transfer phase. Once the dedicated connection or channel is established between end-to-end devices, data transfer takes place. And third one, teardown phase. When any of the end device need to disconnect, a signal is sent to all the switches to release the resources. A signal is sent to all the switches to release the resources. This is teardown phase. After the establishment of dedicated circuit, the data transfer takes place. After all data has been transferred, the circuit is torn down. This is nothing but your teardown phase. Okay. Next comes packet switching. What is packet switching? The packets are passed by a source point to their local packet switching exchange, which is nothing but PSE. Packet switching exchange. When PSE receives the packets, it inspects the destination address contained in the packet. See, here resource allocation for a packet is not done in packet switching. Resources are allocated on demand. Each switching node has a small amount of buffer space to hold packets temporarily and not permanently. If the outgoing line is busy, the packet should stay in queue until the line becomes available. Let's go for the diagram. And as we learned earlier, packet switching is divided into two things. One is datagram packet switching and virtual circuit network. And here, as we have learned about PSC, each PSC contains a navigation directory specifying the outgoing links to be used for each network device or address. On the receipt of each packet, the PSC examines the header information and then either removes the header or forwards the packet to another system or PSE, packet switching exchange, which will in turn route the packet towards destination. If the common channel is not free, then the packet is placed in a queue until the channel becomes free. Therefore, after reaching the destination, each packet is put in order by a packet assembler and packet deassembler. Packet assembler and packet deassembler. So, going for datagram networks, datagram packet switching. Datagram networks are analogous in many respects to the postal service. That is, datagram network service is same as that of postal services. When a sender mails a letter to the destination, the sender wraps the letter in an envelope and writes the destination address on the envelope. The destination address has a hierarchical structure. If the sender wants to send any mail, how we are going to send any letter or thing, we will be writing the destination address also on postal covers or anything where we want to send. Here also the same thing happens. The sender wraps the letter in an envelope and writes the destination address on the envelope. This destination address should be a hierarchical structure. For example, letters sent to a location in USA, the state Pennsylvania, suppose say, the city Philadelphia, and the street Walnut Street, and the house number should be to route the letter to its destination. For example, if a letter is sent from France, the postal office in France will first forward it to the postal center in state Pennsylvania. Finally, to city, a mail carrier working in Philadelphia will deliver the letter to its ultimate destination. In a datagram network, each packet traveling the network contains its header and the address of packet switching address has a hierarchical structure. As the portal address, the destination, when a packet arrives at a packet switch in the network, the packet switch examines a portion of packet's destination address and forwards the packet to an adjacent switch. Okay, see here we are sending the packet and here it is going to the destination address. What is virtual circuit networks? As the name suggests, it's a virtual circuit can be thought of a virtual connection between a source and destination host. Importantly, setting up and maintaining this virtual circuit will involve not only the two end systems but also each and every switch along the VC source to destination path. The virtual circuit identifier, simply we can call as VC ID, will be assigned to a VC when a VC is first established between source and destination. Okay, here a source and destination have to go three phases in virtual circuit packet switching. First one, setup phase, second, data transfer phase, and third one, connection release phase. Here we are going to connect a logical connection in order to establish when a sender sends a setup request to the receiver and the receiver sends back an acknowledgement that he has received add to the sender if the receiver agrees. All the packets belonging to the same source and destination travels the same path. The information is delivered to the receiver in the same order as transmitted by the sender. Okay, here the sender sends the packet and destination, at the destination it should acknowledge. If it is acknowledges only, the sender can, the receiver agrees. Next comes message switching, third one. In message switching, it is not necessary to establish a dedicated path as we have seen in packet switching and your circuit switching, okay, between transmitter and receiver. In this each message is routed independently through the network. Each message carries a header. See, each message carries a header that contains the full information about the destination. Each intermediate device receives the whole message and buffers it until there are resources available to transfer it to the next hop. Here in message switching, we have store and forward technique. So message switching is very slow because of this store and forward. It needs to store the message and it needs to forward the message. In the next hop does not have enough resources to accommodate large size message. The message is stored and switch awaits. Message switching is not recommended for real-time applications like voice and video because it takes lot of time in message switching to pass any message from source to destination. Thank you.